GE Healthcare is really sort of pushing the envelope on driving digital transformation at healthcare. Over the years, we have seen an approximately 5x increase in the number of applications and products that are being developed on the platform and integrated into the GE Healthcare ecosystem. As we look at the healthcare space and as we talk to customers about the difficulties that they're having with sort of, accelerating their digital journey, we found that the healthcare IT is actually quite fragmented. We have customers from small community hospitals at remote sites, pretty large IDNs, and even government and nationwide healthcare ecosystems that have access to private data centers. We want to use the private and public cloud. So GE, when we build our solutions, both internally as well as with partners and third-party vendors, they can be run and deployed across this gamut or this really heterogeneous IT space. We need to make sure that they have the right speed and the right latencies, because sometimes there's patients whose lives really depend on the speed of this technology. There are also things like accuracy, even the power consumption. And so designing to these specs means that all our solutions have to operate across a variety of very heterogeneous compute resources, both for clinical needs as well as just the IT space with oneAPI, where you can now develop these solutions once, but then actually deploy them with very minimal rework on this very heterogeneous compute fabric with many different compute architectures. That's really powerful, and that can really be a game changer for us.
It's a very strong statement of portability of oneAPI when exactly the same code with just different target being compiled for can run on Intel CPU, Intel GPU, as well as GPU from other vendors. So we see that it's definitely a major advantage of oneAPI. Another interesting use case for oneAPI, or maybe even specifically for one of the libraries called oneDNN, is really an ability to program fixed function hardware that really dedicated to accelerate convolutional operation for AI and deep learning inferencing and training. And again, we were quite excited working with Intel and learning how to port, for example, cuDNN code to oneDNN, and it's turned out to be relatively straightforward as well. Once we ported our code from cuDNN to oneDNN, we can run it on Intel GPUs, but we also can run it back on Nvidia GPUs with virtually the same performance as native cuDNN implementation. So from our standpoint, to have this oneDNN tool is crucial to actually enable portability in programming those fixed function hardware functions in the GPU that we believe will be keep growing to address need to accelerate AI and deep learning inferencing. We see oneAPI as potentially becoming a de facto industry standard to program heterogeneous compute systems. And we believe that using oneAPI actually provides us with ability to port our code across multiple architectures and even multiple vendors, saving potentially millions of dollars in configuration cost, as well as many years of engineering effort that we would have to invest if we'll have to completely rewrite this code from one programming model to another.